Okay, we're going to go through an example of solving rational equations. Now, I got the steps right off to the side here, so we'll refer back to them in a number of cases. First thing I always have here is factor first. When you're dealing with rational expressions, it's always a good idea to get the factoring out of the way at the very beginning, because chances are it will make your problems a bit easier to deal with. So let's take a look here. You'll notice I already factored two of our expressions here within this equation. Reason is, these are the easiest ones to factor. I'm looking at 2x plus 7, can't factor that. X plus 4, can't factor that. 2, can't factor that. But I have these and I can factor them. So I'm looking at 2x and 20, right? Sometimes people have a bit of trouble factoring it out using their heads, so I actually like to start out like this. I can use my ladder method. What goes into both 2x and 20? I don't necessarily have to start with the largest factor, but I can... I noticed that they're, 2x and 20, these are both even, so I'm going to go with 2. It's always a good place to start. Divide by 2, oh, okay. And leaves me with x and 10. I can't factor out x and 10 anymore, so I've already factored out the top. So I'm going to write that out as 2 times x plus 10. Let's take a look at the bottom. We've got 2x and 8. Now again, I can use the ladder method if I want. Some people might just be able to say, well, 2x and 8, they share a factor of 2. Just divide them each by 2. That's exactly what you do when you're using this method anyway. 2x divided by 2 is x. 8 divided by 2 is 4. So then I'm left with 2 times x plus 4. And guess what? Since these both share 2's, I have 2 right up here. 2 over 2, that simplifies to 1. So essentially, these cancel out. I don't even need those. So that's why it's good to factor at the very beginning, because it makes your problems a bit easier to deal with. So now I'm just going to rewrite what I have. 2 times x plus 7 over x plus 4 minus 2. Alright, since those 2's canceled out, I'm going to rewrite the problem. I know a lot of people think, why you always rewrite the problem? Thing is, it's always good to keep track of your work. And I find a lot of mistakes are when people try to do too much in their head, or they try and do all this and they can't keep track of all their work. So I always like to write things out. Of course, you run the risk sometimes writing out too much, maybe forgetting something, but I think that's a risk you run because, again, you really don't want to, get lost in everything you've written. All right, so first step, multiply each term by the first denominator. When possible, factor the denominator. Oh, it looks like I lost the 8er here. That's all right. Let's take a look. What's my first denominator here? X plus 4. Okay. I'm going to do that. So I'm going to multiply everything by x plus 4. And remember, I'm not just doing it to that. I'm doing it to every single term here. That's the key. You got to do it to every term. That's what you do in an equation. All right, so now let's take a look. Hey, x plus 4 over 1. These cancel out. Excellent. Next, can't cancel out anything here for negative 2x plus 4. But when I get to here, guess what? X plus 4 over 1. These cancel out. That's my goal here. So now what I'm going to do is I'm just going to rewrite what I have. 2 times x plus 7 minus, and then I'm going to do 2 times x plus 4. And then I'm just left with x plus 10 over here. Now, it says my second step, repeat for each remaining denominator. The good news is, x plus 4 was really my only denominator here. Technically, I could put negative 2 over 1, but that's not going to really change anything. So if I had more denominators down here, like say in theory I had like x minus 1, then I'd want to multiply everything by x minus 1 to cancel that out. But I don't have to do that here, which is pretty cool. Alright, so now let's just multiply this out. 2 times x gives me 2x. 2 times 7 gives me 14. Negative 2 times x gives me negative 2x. Negative 2 times 4 gives me negative 8. And then over here I have x plus 10. So now it says solve for x. So now I gotta go back to my algebra skills here. First I'm going to combine like terms. 2x, negative 2x. Those cancel out. That's cool. Positive 14 and negative 8, those are constant terms. I'm going to combine those. That leaves me with positive 6. So I just have positive 6 and x plus 10. What do I do over here? Subtract 10 from each side. And then I get x equals negative 4. Now, here's what I want to do next. I want to plug this in to my equation here and see if it works. Now, here's the thing. If I plug in negative 4 here, guess what happens? Negative 4 plus 4 gives me 0. I can't have a 0 in my denominator. Let's see if that happens here, too. 2 times negative 4 gives me negative 8 plus 8. Hey, that gives me 0 as well, which means negative 4 is what we call an extraneous solution. It appears to be a solution, but guess what? It isn't, because you can't have 0 in your denominator. So ultimately, I would say that this doesn't have a solution, because when you plug in something that should work, it doesn't. You get an answer of 0. But this is an example of solving rational expressions. I'm going to do another one with you guys too. Let's go with, oh, this is a good one right here. I've already done this one, but it doesn't harm us to do another one. Let's see. Yeah, I'm going to do this one. So I'm going to erase it so I can do it one more time. If you have questions as we go, you know you can always reach out to me. All right. So here we go. Let's try this. This looks pretty difficult to start out, but we can do this. All right. First of all, my first step is factor. Let's take a look. Is there anything I can factor? 2, can't do that. X plus 1, no factoring there. X, no factoring. X minus 1, no factoring. 2, no factoring. X squared minus 1. Wait a second. That's a difference of squares. I can factor that. I'm going to factor that out. Since it's a difference of squares, I'm pretty good with these differences of squares. So I'm just going to rewrite this as 2x plus 1 plus 1 over x minus 1. And then here I got 2 over. Now, an easy way to do difference of squares, I know I need the square root of x squared, square root of 1. Square root of x squared is x, square root of 1 is 1. So I'm going to fill that in here and here. Now, since it's a difference of squares, there's nothing here in the middle. It's like 0x here in the middle. That's, you know, when it's a quadratic, you're used to seeing squared and then something x. There's nothing in the middle. And the reason is it cancels out. That's why we go plus and minus. Because if I multiply this out, I get x squared minus 1x plus 1x. Boom. Those x's cancel out. So I've factored this out. This is a good place to start. Now, let's go to my next step here. Now that I've factored it, multiply each term by the first denominator. And again, that t, I'm just going to put that here. Cool. Take a look at my first denominator, x plus 1. So I'm going to multiply everything by x plus 1. And you can put that over 1. Some people like to see that. I kind of, you know, I get used to not seeing it, so that's why you notice I don't do it all the time. But sometimes people need that visual. You can do x plus 1 over 1. And now let's see what happens. Hey, we can cross simplify. X plus 1 cancels out. Love it. Over here, ooh, they don't cancel out, but I'm going to hold on to that. Over here, let's see what happens. X plus 1, ooh, these cancel out. But I'm left with x minus 1 down below. That's okay. Now I'm going to rewrite this. I got 2, well that's easy, plus x times x plus 1 all over x minus 1. Okay. And then over here I get 2 over x minus 1. Alright, now here's where I would go next. I'd probably simplify this. I've got x times x, which gives me x squared. X times 1 gives me x. So I'm going to go 2 plus x squared plus x, and that's all over x minus 1. And then I am going to have this equal 2 times x minus 1. My next step here says repeat for each remaining denominator, which means multiply by, you know, whatever denominators I have left. Here I have x minus 1, so now I'm going to multiply everything by x minus 1. Remember, that doesn't just happen to the terms that have x minus 1 in the denominator. I got to do it to every term here, so I'm going to do that. Alright, so let's do this out. Hey, right here, x minus 1, these cancel out. I like that. Guess what? Cancels out here too. Does not cancel out here at the beginning, so I'm going to actually have to distribute. 2 times x, 2 times negative 1. So I'm going to have to rewrite what I'm doing over here. Not a big deal. 2 times x, 2x. Negative 1 times 2, negative 2. Still left with x squared. Still left with x. And then over here, I'm still left with 2. So the goal is here, I've eliminated all my denominators. I've canceled them out. Started by multiplying everything by the first denominator. That canceled out the first denominator. Then I multiplied everything out by the second denominator. Now I have to solve for x. So let's go through what I got here. See if I can combine some like terms. X squared, nothing combines with that. I'm going to leave that alone. I've got 2x and x. That simplifies to positive 3x. And then I've got negative 2 here equals 2. Your first instinct might be, okay, I want to get x alone, so let's get rid of this negative 2 here. However, we got quadratic here. Quadratics are a lot easier to solve if you can get this side here, the other side of the equation, to equal 0. So I'm going to subtract 2 from each side. If you're curious, I believe I did do a video on that, so you guys can always go back and check it if you want. Negative 2 minus 2, that doesn't cancel out. That gives me negative 4. 2 minus 2 gives me 0, though. Now, I can use the AC method here. I can use the box method. I've used the box method a lot. I'm going to go with the AC method, because the fact is, I don't have a coefficient in front of x squared. There's nothing here. So the AC method actually works out pretty well here. So what that means is, I need to find two factors of negative 4 that when I add them, they're going to give me positive 3. I can jump to this. Let's say 2 factors of negative 4 that give me positive 3. I can go with x plus 4 times x minus 1. When I multiply positive 4, negative 1, I get negative 4. When I add them, I get positive 3. Remember, that only works if you don't have a coefficient here. If you have a coefficient here, I definitely recommend that box method. Then I get this equals 0. So now I need to figure out what could x possibly equal to get this to equal 0. Now, anytime I have a multiplication problem, because essentially this is multiplication, I'm multiplying whatever this is by whatever this is to get an answer of 0. So anytime you multiply to get an answer of 0, one of those factors has to be 0. So that means x plus 4 has to equal 0, or x minus 1 has to equal 0. So let's figure out what x could be. I could get x equaling negative 4. I could x equaling positive 1. So I have two possibilities for x here. It could be both of these. It could just be one of them. What we do is we check. Let's go back to our original equation. So if we go back here, right? You might have noticed this. You might have noticed I wrote this earlier. So I'm going to write it in again. I'm just going to shrink this stuff down. Hey, nice. So I'm going to plug in these possible solutions. So I get negative 4 plus 1 equals negative 3. Okay, that seems like it's a reasonable denominator. Not great, but I'll take it. Negative 4 minus 1 equals negative 5. Okay, I could take that. Then we get negative 4 squared minus 1 gives me 15. Again, these are all things I can deal with. I'm just double checking to make sure I got this right. Yep, x would equal negative 4. So that's what we're looking for. We're looking for if we're getting reasonable denominators here. And all I did, you'll notice in each case, I just substituted x with one of my solutions, negative 4. Did the same thing here. X, negative 4. X, negative 4. The other possible solution I had here was 1. Let's see what happens when I plug in 1. So if I plug in 1 for x, I could get 1 plus 1 equals 2. That seems like a reasonable denominator. Oh, wait a sec. If I plug in 1 here, 1 minus 1 gives me 0. That can't happen. We can't have 0 in the denominator. The reason why, you can't divide something by 0. Try plugging in your calculator. It won't work. And let's see if I do this again. Let's see, 1 squared minus 1. 1 squared equals 1. 1 minus 1 equals 0. Wait a second. That can't happen. That means that 1 is what we call an extraneous solution. So the only solution that really works here is x equals negative 4. X equals 1, that's an extraneous solution. It will not work. So I wanted to walk you through solving rational equations. So again, remember, first thing you should always do, factor. Once you're done factoring, multiply each term by the first denominator. When possible, it's this factor. Then you repeat for each remaining denominator. Multiply each term by whatever denominators you have left. The goal is to eliminate fractions. Then you solve for x, just like we did. Hopefully this helps you, especially if you missed today's lesson. Take care.